Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Well, good morning, everybody. Thanks for coming, and everybody streaming live as well. So it's my great pleasure today to actually welcome Deborah Estrin to MSR to spend a day with us. And to most of us, like, Deborah actually needs no introduction. She's a very renowned researcher in networking and systems and beyond. And she started out, I think, in career doing internet research, scalable, multicast, robust transport. And actually, I remember, and she stopped doing internet research at some point and moved over to sensor. I interned with Sally Floyd in 2000, and she would constantly lament that Deborah has stopped doing internet research. And by that time, I think it had been 5 or 6 years, but Sally could never get over it, that Deborah had stopped doing internet research. But anyway, in retrospect, it seems to have turned out really well for everybody involved, including Deborah and us, who've seen a stream of really good work come out of her group at UCLA and USC. And along the way, she's picked up a bunch of awards, too many to name, but the ones that stand out for me is the Anita Borg Institute gave a vision for women of innovation, the Brilliant 10 by Popular Science, and the Whitty Hall of Fame in 2008. So without much ado, hand it over to Deborah.
Perfect.
Yeah.
Well, I stopped doing internet research, and then you can possibly decide by the end of the talk or somewhere in the middle that I stopped doing research altogether, but that's another story. One of the things I miss about not doing internet research, and one of the things I missed from the very beginning was Sally. So the feeling has always been mutual. So I do this work with lots of other people, some of whom are named up here, and I'm sure I forgot some. And just to give you a little bit of background, I moved to UCLA in 2000. Took Jeremy with me. And before that, I was at USC for 15 years. And around the time of moving to UCLA, I applied for this multidisciplinary research center from the National Science Foundation that we called SENS, the Center for Embedded Network Sensing. And the whole idea was to do distributed sensing in the context of driving applications because, as Jeremy will remember, we were tired of finding out that we were making up and solving the wrong problems because we weren't working in the context of applications at the time. So that was the beginning of a long, perhaps slippery slope, or possibly a more positive term, of my moving increasingly towards sort of doing what I hope are innovative or useful applications, or both. And from that, looking at technical problems that still need solving. And so SENS is UCLA, USC, UC Riverside, UC Merced, tiny bit at Caltech, and we're in our 8th year. So we only have 2 more years after this, and in fact, those last 2 years will be spent largely sort of transitioning and refocusing to what we're likely to do next. We did a lot of things in the past on what people would call, but it's always a funny term, traditional wireless sensor networks, as if wireless sensor networks were ever mature enough to be called traditional. But so we did applications in environmental engineering, particularly contaminated water transport, in terrestrial ecology, in coastal marine biology, and in seismology. Seismology being really like the granddaddy of distributed sensing. And work continues in those areas at SENS, and we largely expect that those will sort of fork off and be domain-specific activities. For seismology, we introduced some new mechanisms to allow them to do wireless and online sensing. In the other applications, they really didn't do much distributed sensing at all, and so they were really there were even greater impact there in terms of their methodologies. What I'm likely to do, and we're likely to do with a bulk of SENS over these next few years and going off into the future, is what I'll talk to you about today, which is really leveraging a device that, if you stretch, you can call it and think about it as a wireless sensor. It's again, having Jeremy here. Sorry, I'm going to be, because I talk while I think, or sometimes think while I talk. You'll have to hide yourself to not have me continuously reminded. But he'll remember back in the wireless sensor network days when we were the database people came to distributed sensing and thought of distributed sensing or wireless sensor networks as a database problem. And the programming languages people came to it and thought it was a programming language problem. And we came from networking and we thought of it as a networking problem. Of all those, we were clearly, I think, the most wrong in the sense that the networking was the easy part of distributed sensing. It's probably really a statistics problem or a data fusion problem and so forth. And in the process of going through those, building these applications and going through those discoveries and building in the mechanisms that needed to be built in, one of the things that we clearly came to understand was that mobility was key to any sort of economical form of sensing. And I think one of the things that frustrated Jeremy Lugerode, who you might know, and I, who was who stretched all the way back from internet work and moved into distributed sensing, is that in doing that, we lost all of that scale and economics that you have when you work on things related to the internet, because there's so much out there that's deployed. There's so much that you can leverage. You do an innovation, and it lights up a whole bunch of things. And when we started doing this work in sort of statically placed distributed sensors, there's just this economics to it that every sensor you place costs something, even if it's cheap, to maintain it, to calibrate it, every point of measurement. And every point of measurement, if it's a contact sensor, is like it's measuring like a cubic centimeter of the globe. And so it's just the basic economics of it are a different situation. It doesn't mean it's not worth doing. It just means that you want to do it where those data points are really powerful, where they fill in some parameters in a model, where they tell you something about the world, and that by and large our scientists wanted to go out, deploy distributed sensing, study the hell out of a particular area of the globe, and then pick up their stuff and go someplace else and study it. And so mobility happened in that it wasn't just a static sensor network that needed to live for a whole year or 10 years without ever being touched. There are those, but that wasn't the bulk of what the scientists wanted to do. So they moved in that portability sense. And then within any distributed sensing system, you still have this problem that statically placed sensors leave all the space in between. And often the whole problem is you don't actually know the spatial variability that you're trying to measure. And so where you could, which was not in the soil below ground, but in water and above ground, the ability to move a sensor through the environment and take multiple measurements as opposed to being stuck in one place had great economy and scalability to it. So from that story of looking at mobile sensing, and from a random invitation from Nokia Research Center to a workshop that they held back in 2005, and a project that they launched called Sensor Planet, where they gave out a bunch of phones. So suddenly I had, instead of having to pay for every mote that I then had to package and get put out somewhere, suddenly I had 300 relatively powerful mobile phones, and what could we do with these things? So we started really with that question of what can we do with these things, and from that perspective being relatively application driven. And so now what I want to tell you about for a bulk of the talk is about some of these applications we've built and that we've been using in an exploratory way. As very much compelled by this availability of the technology, that it's not just that the infrastructure is out there in the cell towers and all of that, but that people are very attached to their phones, carry them in their pockets, and therefore the power of leveraging that existing infrastructure and adopted technology is very compelling, and looking at problems that seem important to solve at this particular point in time on this planet. And that's one of the excuses I have for being in academia. I don't do theoretical work. I don't do particularly far out work in terms of being very futuristic, because I tend to do things with all sorts of components that exist. But so one of the reasons I stay in academia is because I try to work on problems that don't have any clear revenue stream. And so while some of that might change with some of these things, that's sort of a common theme. So a lot of my slides will be talking about technology. Often when people give research talks, they're talking about what's difficult. And when I look at this sort of body of work, or sets of activities that we're doing, it looks to me like all things that are easy, not difficult. And that's part of what I find so compelling and exciting about it, is so much is so easy to do. I do think that there are some hard problems to be solved that follow on that, so I don't scare all graduate students away. But really what I think is most exciting about it is how easy everything is. And also in sort of reflecting back on this set of slides, and this is by no means a complete list. This was really just from recall. I just wrote down there are so many building blocks and precedents that come from this place. Well, not this building, because I guess you weren't here for a lot of that time, but this place organizationally. So using GPS traces, spatial cloaking, radio as sensor, thinking of Victor's work, reality sampling, map crunching, activity classification, many, many things. So I don't know if you guys are in the audience, because I'm very bad with names and faces, but lots of pieces that are very, very related. I will also use this sort of blue variable font, because I'm not careful enough to get at the right size font, down at the bottom to talk about some of the research challenges that underlie taking the applications to the next step. So let me start by talking about I'll spend a fair amount of my time talking about 3 types of applications. And I'll be fairly specific about them. Many of them have, this is my mark for something being real these days, is do we have an active URL that represents, that project and isn't just a static web page? And many of them do, and I'll try to be coordinated enough to flip over to the web page. So the first class of applications I'll talk about are really the absolutely simplest and easiest in terms of the underlying technology. And this is just that incredible thing that we know as the geocoded image, right? It's just that thing that's possible on all smartphones now is you take a high quality image of something, it's automatically geocoded, automatically time-stamped, and automatically uploaded. The most mundane thing possible. People do it all the time with Flickr and other photo repositories. And the idea here is just that instead of having basically images be organized by who took them, okay, which is how people tend to organize their photo albums now, think about a data campaign as a particular purpose for which you want evidence. It's really just a make a case technology. And so the basic model of operation here is that you have it's a combination of mobile and web. You have a downloadable app, just like that you get from the App Store or the Market or whatever your favorite app type store is. You download that app to your phone. It has a very visible, recognizable icon. You click on that icon. It has you do a prompted capture. It gives you an offer of some tag information, some specified tags. You capture it in basically a click, possibly tag it. It's uploaded and automatically then curated and presented on a live website along with everybody else who's contributing to the campaign. So one of the first campaigns we did was with a class on campus, a group of kids students who are part of a sustainability initiative on campus, and they were trying to make a case to the campus to put out more recycling bins. And so it's a lovely set of images, I guess we are relatively close to lunch, where you can go and see, and basically the campaign that the students had was go around campus, every time you see a garbage bin every time you see a garbage bin, take a picture of it, tag it whether it has recyclable items in it or not. And they actually ended up creating a map. The map was automatically created, and they ended up writing a whole report that they gave to the facilities office at UCLA about placement of garbage bins and overflowing garbage bins and a whole bunch of other things. So what's interesting about it is that it's no computer vision, not a single difficult technical problem in the way of it, not something for any one campaign that you would go to a lot of effort to do, right? This is not something that's important enough for you to bother investing a lot of money in. But at this point, we have this thing that we call the Rapid Campaign Platform, and it's just probably an hour or so of changing some scripts on the website and changing some code on your downloadable app, mostly in terms of the visuals and the tags that are offered to you, and you have yet a different campaign. So a subset of the same class was looking at food waste in the dorms, where they have a cafeteria plan. They're trying to get the students to take less food on their plate so that they waste less food. And so here they're taking pictures of food as it goes back on the conveyor belt, equally appetizing. Also, just the same basic idea, right? Do something on the web that's there to automatically curate, that indexes into the images either by time or by spatially on a map or by tagged value. Now, I showed this to a guy who came to visit me on Friday, who runs a bunch of the DWP, the primary utility down in Department of Water and Power down in Los Angeles. And he immediately wanted this for his employees who tool around town all the time looking for things having to do with wasted water use, broken electric utilities, broken electric meters, things like that. And now they write down reports, they come back, they enter into a database, right? So he wants to just be able to generate quick campaigns for the top 5 or 10 things of the week that they're looking for. And they go to that particular app. And the point is that the data is automatically, because of those tag values, geocoding, timestamping, automatically curated. They can then do triage once a week or every morning, for that matter. Where are the primary problems? Should they go out and allocate resources? Just very, very simple. Now, all kinds of things you'd like to be able to do. A lot of work here for image analysis, computer vision, some of which is zero research, just hard work applying some of the existing techniques that already are there. But others of it, that is research, right? Category recognition and computer vision is not a solved problem by any means, and you'd love to actually be able to apply that problem over time, not just get rid of bad images and give people data integrity feedback. And then as these things get successful, having campaign management tools of where you're missing data, reminders, and things like that. Okay. So that same story applies, that I sort of think of as civic engagement. Same story applies to citizen science. I never really believed in citizen science. I thought citizen science, many activities in citizen science were acts of marketing, okay? And that there was something false about them because you would dumb down the doing of science enough to be able to get the public to engage, but the data they would generate had no way of being validated or really used, and so it felt to me like very false pretenses, this sort of in the same way that sometimes when they try to teach kids math with sort of cartoony simulation things that take away all the messiness of it, or if you, that I have that same ambivalence about it. So, but using geocoded images in this way, as a way of citizens contributing data, is interesting because it has an automated validation, sets of validation points. Because it's geocoded and timestamped, because the image speaks for itself, even though it might be tagged incorrectly. And so we've been working on a couple of different, let me try this, a couple of different applications in citizen science. Let me see if I managed to do this. Now what am I supposed to do that? Okay. And I couldn't get on your open Wi-Fi. Not that one, this one. So these are all live URLs, what'sinvasive.com. And so it was the basic idea of doing this citizen science thing. And we started talking to the National Park Service. So LA, yes, it's environmentally a disaster zone and a ridiculously designed city, barely a city and all those things, but we do have the Santa Monica Mountains, which are nice for biking and hiking and those sorts of things. And they're an important ecosystem. And much of the park area is managed by the National Park Service. And one of the things that they need to do to try to maintain the ecosystem, aside from trying to keep it from always burning down or being developed over, is to manage invasive species. So invasive species are a problem because they come in, they take up all the water and the nutrients, and they crowd out the local plants, and then the rest of the ecosystem, the bees, the insects, et cetera, changes as a result. There are many invasive species growing all over the Santa Monica Mountains that are already so prevalent that there's nothing you can do about them. You'd have to eradicate everything to get rid of them. But they have always the top 6 to 10 weeds, their top 10 most wanted list, that they're trying to spot early incursions of them so that they can eradicate them because they're still at a manageable level. Think about any kind of preventative disease problem. This is just an ecosystem disease. And so we said, okay, that same thing we did for garbage watch. First of all, we'll have some prettier pictures than garbage and food waste. And we just went out to their facility staff and said, here are 10 phones, and here's how you use them. And we set up this website, and according to we got from them their top 6 weeds, and we gave them tags. And then this is the map that just gets automatically generated by them clicking on it. It's geocoded, it's time-stamped, it's tagged by the weed, right? And then you end up with this kind of a map in real time. Now, normally, the last invasive species survey they did was 3 years ago. It took like a year to collect the data and another year to get it online and process it and do whatever. And now, by the time they did that, they were about ready to start the next one. We actually have some nice plots that Mark did that sort of overlays this on top of their 3 years ago invasive species data from 3 years ago. And they did this in 10 days without any coercion from them. I mean, we just gave them the phones, and as they're going around as part of their daily work, patrolling the parklands, they would go ahead and do this. So now what we want to do is also make it available to hikers and things like that, to really engage citizen science. Interesting question. We almost were only looking to do this for the sort of the public and hikers, but these employees who are always out and around, whether it's the DWP's guys or these guys, is actually an even more interesting target in the same way that you were talking about going to small enterprise before you go to the home. I think that there is some really interesting market there, if you will, not necessarily revenue market, but in terms of early adopters. So to do all this, and as you were saying as well, it's really not to publish papers that we were trying to sort of develop a basic framework, just that we're doing lots of these, right? And you go and talk to somebody and you have 5 new ideas every day about data campaigns that people want to do. And so the things that have let us now do like, a dozen and moving on numbers of campaigns is just building a very simple, making a lot of use of the cloud. We happen to store these images on Flickr and pull them back down, and then we have some analytics stuff going on. And for the most part, you get feedback on the web, and then we do feedback on the phone as well, particularly in terms of your participation contributions. And lots more to be done here, but this is all done using the same basic set of software and just modifying some PHP and Python scripts. And then a little bit on the we're doing this mostly on Android phones, or still we have some that are working on Symbian. And we've done some of our work in Windows Mobile, but basically in this way, whoever gives me phones, that's what I work on. I mean, the pragmatics of it, I can't do big campaigns if I have to buy the phones. So you give me phones, that's what I work on. Good phones. Huh? Not less than 40. Okay, 4 phones don't do me any good. We have like 4 or 5 Windows Mobile phones, and that's just about how, so we did some parallel implementations. Or you give me a customer base, right? So nobody is ever going to give me an iPhone, but we are building an iPhone client for some of these things because that's the only smartphone that I can count on people having out there in the real world. So this is sort of grown up into some of the thing that is maybe not as completely mundane, still very doable, and where some of this is going, is tying this much more into all of the remote sensing and GIS data and other both model-based and empirically based data that exists. So we came up with this idea of sort of what we call our pixel. And the big picture is, if you think of every pixel of a global satellite image, to not only have the reflectance data that it has now, as well as other sophisticated sensors that are going on satellites, but also to encompass the local knowledge about the land, about the practices, about what's going on. So we often would talk about how that the tagline behind SENS was about spatial resolution, and that every pixel in a remote sensing image represents an average over many, many kilometers, and so we wanted to get to something lower spatial resolution. But when you think about what people can capture with mobile phones, it's not just about visible spatial resolution. There are also multiple perspectives about what's going on that piece of land. If you think about even that invasive species story, and that's what we're sort of using as some initial concrete fodder for this. There's a lot that you can use if you look at remote sensing and use that as a guide to where you're doing data collection, but also you can then support investigating places where there are interesting different perspectives, such as related to land use. So there's lots of controversy about building school. There's a school actually in my neighborhood that's been it held up through a court proceedings with the local neighborhood for years now because it's claimed that it's going to have too much encroachment on the local wildland. Many issues between neighbors and the park and neighbors and one another. And if you think about it, the ability to document what's going on in a particular place with local perspective is interesting. And our pixel does that, as well as trying to tie together in a more integrated online way what's available from remote sensing and GIS data with these local observations. And I wanted to mention this in particular. Once again, we're sort of building it out of as many existing and open source components as we can. And thanks to the Jim Gray funding that we received from you folks, we're hoping to make some significant progress on this this summer in particular. It came just in time. Money made available right before the summer is much more valuable than money made available, then particularly small amounts of money. You can do a lot compressed time in the summer, more so than you can like in the fall or winter quarter. And we also have a collaboration brewing with Conservation International. We actually did some early work with them on using the mobiles in something called an eco-PDA for their teams of semi-professional data collectors that they hire in the tropics to monitor biodiversity. So instead of them writing on Write in the Rain paper and coming back and entering that online, they actually put it into a PDA, and very similar to the rest of this to the rest of the story. And with Sandy Edelman, we're actually trying to get some funding to make some serious data campaign happen in time to possibly demonstrate for the Copenhagen climate change conference in December, although that's getting a little iffy. The idea being that nations similar to Kyoto, having to do with carbon reduction, have also made commitments to maintaining ecosystems in order to do the balance of CO2 generation and sequestration, but there's no way in which they don't really have monitoring capacity for that, for those commitments that they've made. Moreover, there's a lot of interest these days in, every time you go and make a plane reservation, they ask you if you want to pay for your offset. And so there are lots of schemes, I will call them schemes, coming up as to how what those carbon offsets can pay for. And some people have been trying to tie carbon offsets to poverty alleviation, so that instead of just paying a government to plant a big forest, you pay subsistence farmers to plant things, but you want them to plant the right things. And how in the hell are you going to monitor it? Right? The cost of monitoring that kind of a thing is incredible. So can we think of creating a kind of challenge response, verifiable type of campaign where with images over a course of time, you can verify that it's the right kind of tree in the right place? Yes?
If all of this is driven by volunteers or something, that would be kind of like a self-selected set. Mm-hmm. So you'll get documentary evidence in only one direction of the debate. And is there any way of getting around that?
Yeah, so for example, Conservation International pays people. It might not be their full-time job, but they pay local populations to go out and do data capture. And because they see where they've been and when they've been doing that data capture, they can identify where they're getting coverage. And a lot of that is driven then by remote sensing GIS-based analysis of where they want to be. You're not going to cover every cubic meter of the globe. You do experimental design. You decide where you need data from. And then, so there's the notion of paid. In this context, where you're talking about doing verification, auditing these mitigation activities, there, it's tied to your having somebody plant something in a particular place. They're getting paid for your offset, and this is verification of that over time. It's not volunteers. It's going to be a requirement. If it happens at all, it's going to be a requirement associated with receiving that offset funding. And that question applies in many different contexts. So if you think about in the civic context that I was mentioning before, you can't... people will use it to make a case that's the case they want to make, and you're going to be hearing from the people who complain as opposed to the people who don't. the facilities, but that's why sort of this DWP guy wanting to use it for his employees is an interesting alternative model, because they sort of peruse the county as part of what they do, and then this just becomes a very easy vehicle for them to do that. Okay, so that was my story for lots of things we're doing with just the most simplest of things to do, which is geocoded images that are automatically curated and automatically processed, that have behind each of them, I'd say the only difference is that there's a particular purpose, a particular theme, a particular thing you're trying to do with it. And every campaign is freshly generated with that. Okay, so now second of this set of things I want to tell you about are making use of a different, as readily available, but a little more interesting processing to do, which is that wonderful thing, the location trace. Okay, so so how we got to this was we were actually doing things with automated capture of images for this nutritional sort of dietitian epidemiology study that somebody was interested in, where we had these phones that we were slung around our neck, programmed outward-facing camera, automatically capturing images every 10 seconds as a form of input to like a 3-day dietary assessment. You're not Gordon Bell, you're not going to walk around like that all day and all the time. But if somebody's doing a dietary assessment as part of a food elimination or what have you, instead of filling out a 3-day retrospective report, you would capture these images. They would be curated. You'd get a sample for during your day. The individual would look at them and use that to help to trigger their self-report that they're filling out. Why were they looking at them as opposed to nutritionists? Because outward-facing camera taken throughout your day has some serious privacy issues with respect to not the person so much, but everyone around them, including their half-dressed family running around while they're at the breakfast table. Or as caseGÇ, the best thing he ever did for me was when he came to a research review of mine, and he enacted a story that I had told as an imagine if, which is that he walked in the men's room with his outward-facing camera on, and we were in real time, popping up all the images. Just anyway, it was great. So where was I? Got off my tangent. Okay, so. I try to run all these systems that we use, particularly now that we're working in applications in this sort of urban sensing space. That's easier for me to be a guinea pig. So I was I was going around with this camera around my neck. And as Jeremy will know, first of all, I don't spend a lot of time at meals, right? So all it would see maybe is every once in a while is a protein bar coming in or out of the image, or it wouldn't be caught. Second of all, I spend a lot of time in my car because I have a long commute. So most of my images were of my steering wheel, okay, every 10 seconds, and of this, some protein bars or fruit coming in and out of the image. Not particularly interesting. And it was sort of distressing. And then I also decided that technology in general, while I think it has its niche applications, just doesn't have a lot of scalability, because the privacy stuff about taking images all the time is just too much. But the geolocation trace, forget the images. My images were completely boring. But just my GPS time series, and you guys had already been doing things with this before, but it wasn't until I was doing it myself that I realized the power of that, right? So I started thinking about, okay, this GPS time series, well, first of all, you do something, you sort of do, in some sense, it's just a mashup on steroids, or just, a crunching together of maps. So first of all, what happens when I just see my GPS time series throughout the day? Okay, so that spatially tells me something, and it's sometimes interesting to see just how repeatable your patterns are. But I started thinking more about this as, what can I infer from this GPS time series? So of course, as you know, and work done here long before and at Intel and many other places, from a GPS time series, you can do activity classification. So now I have an activity time, location, time series that's easily collected throughout my day, throughout my week, throughout my year. So that by itself is of interest for different things. I'll mention an application when I get over to health. But what we did with it was build a system called PEER, where it's this personal environmental impact report. And so from that GPS location time series, we did course activity classification. Are you indoors? Are you outdoors? Are you driving on a highway? Are you driving on a surface street? And by using that by using that location time series as an index into models that the Air Resources Board maintains for things like air quality levels, PM 2.5 is the most harmful particulates. I'm not measuring PM 2.5. It's not a personal measurement of that because I won't go into that rant, but the state of miniature sensors that are going to do high quality particulate measurement are far from where you would want them to be, but they maintain dynamic models of what the PM 2.5 concentrations are. And it's based on climate, it's based on some coarse-grained static measurements, big instruments that are out there, as well as some occasional drive-around maps that they do with also significant instruments on the electric vehicles, as well as traffic reports. Okay? So there is an exposure map for the area that's dynamic, and now I take my location trace and I use that as an index into that map, and I get an estimate of my PM 2.5 exposure, just like I get an estimate of my personal carbon, of a personal carbon calculator. So that's what we did with PEER. We took this location time series that is going up to a website. It's a private account on that website, activity annotated, run through these models. And the models that have been most useful have been the CO2 calculator and the PM 2.5. We also did fast food exposure. How much time do you spend sort of still around places that are intensive, that have many fast food establishments, and there are standard measures for that. And because food availability is one of the contributors to health disparities. And we actually have a trial that was running with some high school students in the Bay Area in San Francisco, where they were doing these high school classes were competing against one another as to who could go greener by changing their transportation modes. And instead of doing it through self-report, Nokia gave them a bunch of phones, and I think AT&T gave them a bunch of SIM cards, and they were running PEER on it, and we made a special Facebook widget for them because we didn't have the PM 2.5, we didn't have the air quality model integrated for San Francisco, but it's just a personal carbon calculator, and it shows what their scores are relative to their group average. And they got a lot of good press, and they're hoping to continue it. So one of the interesting things here is that the processing pipeline isn't trivial. Not big research, but serious software engineering. And in fact, PEER as we have it can handle a few thousand people. I actually think it's an interesting tool for like a city to use to say, okay, this is commuting optimization month, right? Run the PEER tool, see if you're going to choose to work at home a day a week, or ride share a couple days a week, or do a bus commute one day a week. How might you shift your schedule, and which day you might do that to overall improve your overall impact environment. There are things you can imagine that an employer might do that for their set of employees. Again, it's not something you run every day of every year, but if you want to do some analysis to see how to optimize your commute around these things and raise awareness, it's an interesting example. But to do that, we're now this summer actually spending some time retooling the processing pipeline. And as you think of other models that you might want to run these things through, this becomes a nice, challenging, just sort of software engineering effort. And of course, many of the models you might want to use, as opposed to being nice live models up on the web with good APIs and things like that, they're not. They're like chunks of Fortran code sitting someplace that you have to figure out how to get up and live and be able to index into. So that's even true for this Air Resources Board data that you have out there. One of the derivative projects that sort of combines some of that geocoded imagery and some of what you saw in PEER is a project that came up through some of the students. And this is about bicycle commuting, not the weekend cyclists who go out for exercise or weekend activities, but to trying to promote bicycle commuting in Los Angeles, which, if you know Los Angeles, is a bit of a challenge, right? Los Angeles is built for cars. It doesn't particularly have any buses, it has no trains, and it certainly isn't a great thing for bicyclists. But as gas prices for a while there were getting up to where they should be, people were starting to look more and more at cycle commuting. And so the idea here is just you take your phone, it's doing the GPS time series, and it's timing your route from start to finish. But it's not just doing that. It also has, because of the accelerometer, it's capturing a measure of the bumpiness of the ride. And it's also giving you back statistics on how much of your ride are you continuously moving versus stopped, assuming at an intersection, breathing in exhaust fumes, and probably more a source of safety concerns. So the cycle commuting community, so far we've just have a couple of users using it, but we're hoping to do more this summer, particularly once we get the iPhone client, because that's the only smartphone that people have in large numbers out there. It's an interesting I don't know if this is the most up-to-date URL, but I'll get it to you. And it's an interesting application that makes use of both location time series and makes a couple of inferences out of that, not just duration of ride, but as I said, quality of ride. So the last set of applications I want to talk about are in the context of health and wellness. And one of them is basically the same thing as, if you will, as Peer or as Biketastic is using. I did not come up with that name, but I showed my maturity as a boss by accepting that name be used, even though I can't barely get myself to say it. This was actually, this is just about using that location trace in other sorts of contexts. What does your mobility trace tell you if you're managing some kind of chronic disease? So that chronic disease might be aging, or that chronic disease might be Parkinson's, or MS, or muscular dystrophy, or many other diseases that introduce not just neuromuscular, have neuromuscular impact, but also just diseases that introduce fatigue, either the disease itself or the treatment. And so ambulation, which is a term. So I was giving some talk about some of the stuff, and somebody at the NIH put me in touch with somebody who does a lot of IT work for the Muscular Dystrophies Foundations. And they explained that their kids who have muscular dystrophy, the way they're evaluated is that they go into the doctor's office once a year and do a 6-minute walk. And that's the evaluation. Can you walk for 6 minutes in the doctor's office? And so the woman who heard the talk said, seems like it would be relevant to this guy, Kyle's community. Why don't they run this kind of activity classification? Then they can have, even if they don't need it 365 days a week, even if you do it for a week, once a month, okay, or 2 weeks, twice a year, you get a picture that's a much better sample of what your actual life looks like and what your mobility patterns looks like. So this is just doing GPS plus accelerometer to do activity classification of walking versus slow driving and other things. Accelerometer helps a tremendous amount. We have a lot more work to do to perfect the activity classifier. And for example, they want to be able to do wheelchair versus car versus walking. They want to be able to do steps versus not. And there's been lots of prior art in that area. But it's just an example of a very simple application of the same technology. Now, in some cases, it might be this kind of diagnostic, do it for 2 weeks. In other cases, it might really be something that, because it's so easy to be passively collecting it, you might just want to do it all the time. Because then as you're looking at shifts in medications or how was I relative to where I was last year, you can go back and look at your mobility statistics. And there are indicators also that might generate sort of events. For example, one of the indicators for these populations is when people become less confident in their mobility, they stop going out as much. And it's not something you announce to anybody. It's not something that happens over the course of a day. It's just something that sort of gradually sneaks up on you. Same thing is something that I noticed in my aging parents. When I finally found out that 6 months before they'd stopped cooking at home, that they were always taking their main sort of meal outside in the home. And it's just an indicator of something. It has dietary and sort of nutrition implications, and it's an interesting indicator. And it's something that their location trace would tell me, or tell them over time. I'll come back to the privacy issue. And then the other sort of dominant mode in which we're doing some initial health applications is a combination of some of that location trace, but it's going back to what I started with, which is the geocoded image. But added to the geocoded image is something even more mundane than the image, which is asking you a few questions. So the term ecological momentary assessment is what some of the social scientists use. You guys call it, is it you guys who calls it reality sampling? Is that you? Am I confusing you with Intel? Probably, sorry. So reality sampling is another term. Robert Wood Johnson Foundation calls it observations of daily living, which is actually, I think, the nicest of the terms that I've heard. And this is, again, when you have that nice, really good quality displays that we have now, touch touch screens and such. It's really easy to answer very quick sets of questions. Hi. And so this application, which we call generally and wellness, this particular instantiation of it is just, this is instead of that automated image capture around the neck, right, with all its issues. This is this location and time triggered query about what you're eating. Okay, now, all that's happening here is that geocoded image is being tagged with some quick information about what the health folks told us to ask, which is how full are you, is it good quality, were you on or off plan, because it doesn't matter what diet you're on, it only matters if you stick to it, and what was the duration, and who are you eating with, possibly. Yes?
Did you discover anything about people eating better when they're forced to take photos every time they ate?
Okay, so first of all, in case anyone from my IRB ever listens to this recording, you will know that this is a technical trial. And we were not studying anything about human behavior, nor would we ever. And then more seriously, we haven't had the numbers to know whether reactivity comes into play. So for the epidemiologist, you know, that's like a huge issue. And for the health behavior people, that's great. Right? That's part of what you want. And so we have like a zillion different versions of this into NIH with our health applications folks and our Robert Johnson Foundation, because we'd love to be able to answer those questions in terms of the reactivity. And then most likely that reactivity starts to fall off, as does participation. But there are all kinds of fun things you can do with this, because this is the device that's in somebody's pocket. You can do location reminders. You can do different incentive things. You can do social networking things. And it just all is just a small matter of really probably very simple programming, but not so simple user interface design. Yeah.
So is taking the picture just a trigger? Because you don't have to take a picture to.
No, you don't.
Right. You just.
And in fact, the prompt doesn't make you take a picture. It's just one possibility. And sometimes people find it interesting because it helps them remember, and it tells you something about portion and things like that. And sometimes you just don't bother. Now, this could also be about medication adherence. And again, that's just that it's very easy to use, and it's automatically curated and in real time. And the point is to be able to go back and see your trends over time. This is automatically generated for you. Go and see, where are you off plan? It's not going to automatically change your behavior. There's a little reactivity. More than that, it's to say, where do I tend to be off plan? And then maybe talk to a diet coach or whatever about, okay, what can I do to try to change that behavior? One little step at a time, because that's how behaviors change. So if the problem is, you know, eating ice cream, so Mary Jane Rothram Boris, runs this big NIH-funded center at UCLA, I like her example best. She explains that at 10 o'clock, she eats ice cream, okay? But if she remembers to buy strawberries on her way home and eats strawberries at 9, she doesn't eat ice cream at 10, right? That kind of a thing. You know, the power bar at 10 instead of the pastries off the, office cart at 11. And so we've done some, I actually hired my first user interface sort of person from somebody who graduated from the DMA program, Design Media Arts program at UCLA. And so here, if distributed sensing with statistics problem in this domain, maybe everything is a user interface, user experience design problem in the end. And lots of questions about how you chunk this stuff up to make it useful, incentives and feedback and customization. And so we just put in a proposal to the Robert Wood Johnson Foundation. As I said, they call this Observations of Daily Living. And they wanted people to target populations that have two diseases. So we did hypertension and diabetes that often occur in common, usually along with obesity. And there we have physiological measures, so blood pressure, glucose. It might be Bluetooth, but it could just be a regular, standard device that you then enter in whatever the reading was or take a picture of it, what have you. There are then patient reportings of things that there aren't measures for yet, or we don't expect them to be in the near future. So medication adherence, yes, people are coming out with the automated pill boxes and all of that. But in the meantime, you can also ask people to take pictures of that. Do any of you spread your vitamins out in the Monday through Sunday pill box kind of a thing? Just think about taking pictures of that. Really mundane, cheap ways of doing similar kinds of reporting about adherence, about symptoms. So one of the biggest problems in those disease populations and with chronic diseases is this actually adhering to medication, taking your medication. There's like a 60% drop-off rate in hypertension cases because the disease is relatively invisible next to the symptoms next to the side effects of the medication. So the medication can cause dizziness and all kinds of things that just make you feel crappy, and the disease at that day-to-day level is relatively invisible. So you really want to allow people to titrate their medications and get it down to the right dose for them. But it's difficult because there are delays in the system, and it really requires this kind of a monitoring to be able to make that correlation. And so the idea is if people could do much, not all the time, but as they're trying to get their medication to the right level, and then it's not something that's steady, right? As people's situation changes, there are either their disease condition can change, or other things can change that make their doses change. Whenever you do one of those shifts, you go through this period of trying to record your symptoms as you're adjusting your medication. And this along with location traces, because somebody can talk about fatigue, or you can ask somebody retrospectively in their monthly visit to the doctor, how have they been feeling? But how have they been feeling is all through how they're feeling right now. Whereas if you just go look at their location traces, even if it's just every Monday or twice a week, or it could be all the time, you can see fatigue and depression and changes in fatigue and depression just in when people get up and go to work and how much they go outside and what they do on the weekend, which is something that is a good segue. So all of these things have this common kind of framework. Data capture, processing might be on the mobile, might be on the website, might be back and forth depending on how much you're training it or not. And then applications based on models and archive data. This isn't something I want to run just on my phone because I want to be able to go back and look at data from a year ago and look at trends and those sorts of things. So even if my phone gets very, very powerful, the web is an important component of this. So finally, I just want to end the talk by talking about some of the architectural opportunities. Architecture is a big word. Some of the things that are common across these civic applications, citizen science applications, sort of personal sustainability, transportation applications, and health. In particular, as I was just starting to say, there really is a common workflow that we see here, and so this should lend itself to middleware, APIs, whatever the hell you want to call it, and certainly lots of uses of things like activity classification modules, something that is definitely something we don't do well, that is at least some very serious design and development and application of machine learning. I don't expect that it's necessarily research in machine learning in terms of needing new machine learning algorithms, but making activity classification something very personalizable so that I can increase its accuracy is just calling out for some serious attention. So in the same way that, I'm using all kinds of politically incorrect analogies here, but what the hell. So when you start, open up your Palm Pilot, right, and start up graffiti, you would click, are any of you old enough to know this? You would click on the four corners of the screen, and in the middle, right, to do it a calibration to your touch. A better analogy is voice recognition software, right, where you go through some scripted phrases to have it adjust to your particular accent and pronunciation, and you really want your phone to do the same thing. And so Hossein Falaki will be here this summer. And it's a good thing when an advisor who's only been working with the guy for a year quotes their graduate student. So, Hossein has this line that he says, a month or a year after you've gotten your phone, it shouldn't behave the same way as it did when you pulled it out of the box, right? It should adapt to you. And that's true in terms of power management, and it's clearly true in terms of the kinds of activity classification. So, like activity classifiers that are used for peer or by tastic or what have you, as I said to my students many times, if it ever classifies me on a bicycle, okay, a bicycle shouldn't be even in the realm of possibilities, okay? My only relationship to bicycles is that I try to avoid them when I'm running, but I don't go on bicycles. So how much better can my classifier be if you just know that I'm never on a bicycle? So simple things as well as more complex. There's a lot of role for common modules, mechanisms, algorithms, and such in that context. But perhaps the most challenging of these things, or challenging of the commonalities across these applications, has to do with privacy. Again, something that was identified here early in all the work that was done here on spatial cloaking, and is here, when we're talking about on a routine, and all of that was like way before everyone had these GPS devices in their pockets all the time. And here we're talking about applications where it's not just that you can go and subpoena information from the cell phone provider, but in fact, people, for their own use, for getting discounts on insurance, for being part of some social networking application, what have you, will be archiving information continuously, or at least for significant periods of time, about their location traces. And so many potential consequences. We all have visceral reactions. Some people have a visceral reaction, which is that I have nothing to hide, it's no problem. Most people who have that reaction will, though, agree to the fact that just because they feel that way doesn't mean everybody should feel that way. And so if you look at things like GINA, which is the legislation that said that you can't be discriminated against based on genetic data that might be available about you, that was put out there in part because even if somebody chooses to make their information available, they shouldn't be able to set the precedent that other people should be coerced into making that information available and be discriminated accordingly. And the same kind of thing can play out about your location trace. There is no information that is so easily collected and that tells so much as one's location trace, right? Images all around town, all around a city, all around an airport are still relatively difficult to process in large numbers. It's a much more technically challenging job, and they're not always with the person. This data is so easy to mine, and so consequences having to do with like location-based discrimination, okay, being denied insurance because you spent 5 years of your life living within 300 meters of a major highway, which is later associated with a threefold increase in getting something. For that matter, not of all of this requires location traces. It could just be based on your address. So, for example, if you live in the Long Beach or San Pedro port areas, you're exposed to particulate matter levels that are 3 orders of magnitude higher than when you're sitting on the 101 freeway at a crowded time. Not 3 times, 3 orders of magnitude, because of all the port truck traffic that comes in and out of the port area. So many issues having to do with health that could end up relating to that kind of discrimination. But coming to things that are nearer at hand, just think about those professional boundaries and even those personal boundaries that have to do with complete accountability about where you are and when you're there. Some of them are just sort of in the category of trivial, tiny white lies. Some of them are about how we manage our busy lives and juggle all the aspects of it. That notion that I can now be accountable for where I am at every time is a change. That DWP manager that I talked to, who I had this great conversation with and immediately wanted to go use this application, was also very excited that he would now have complete information about where his workers were actually all spending their time all the time. So we've been looking at this question of how can we build into the architecture to give individuals some control over their time-space accountability, to still want to be able to share it, right? The answer of just never sharing isn't interesting. The problem is that people do want to share subsets of this information, and as you guys showed, many, many years ago with spatial cloaking, you can't just make location trace data anonymized because you lose you lose so much of your data. So we've been looking at an idea of using something that we call a personal data vault. Recently have been talking to Monica Lamb at Stanford, and she has something that she calls a butler, which I told her that I thought was really strange language, and then she reminded me that we talk about master-slave all the time, so why was I giving her this hard time about using a politically incorrect term? If anyone can give me a good answer to that, I owe her the next retort in the email, so I would appreciate it. But so their butler concept is a similar one. That's a big project. They have Monica and Nick McEwen. And the idea being that my location trace should be owned by me and should be, in its raw form, should be available to me historically. Again, I don't want to just keep it on my phone because I want it available for this kind of analysis. But I don't want to necessarily, I want the ability to store it independent of anybody who has commercial interest in mining it. Okay, so this is something we started talking about before Latitude was announced, right? But in some sense, it's no, let's not have that be the only way in which you can go about things, which is that you are sharing your location traces directly with a third party who has, even if not anything at this current moment, will in the future or could in the future have an interest in mining that data. Okay? So I want my raw data, my raw personal data streams, to coming into a private data store, and then the hard part becomes actually negotiating to whom I release those streams, what statistics am I going to release. I can reduce the spatial resolution, I can provide it for certain periods of time of day, and so forth. And so we're building with Ramesh Govindan as a collaborator on this, and we're also working with a legal scholar colleague, Jerry Kong, at UCLA, on what kind of protection we might be able to have. You know, ideally, you'd like this to be subject to privilege, in the same way that your doctor can't be subpoenaed to give out information on what you've told them because there's privilege in that relationship. I would like it to be that this sort of passive data that I'm capturing about myself is not automatically necessarily subpoenable as well. So many precedents for this. Some aspects of this are just very simple. I'm not talking about a physically centralized vault. This would be something that could live out there in the web with all kinds of existing encryption mechanisms and such to protect it. And of course, the hard problem has to do with when you start to release information. And so this is all just very much work in progress. And some of what we're trying to support then is not so much trying to make sure that I know what happens to the data that I release and that I've already released, but giving me back enough diagnostic information over time so that I can decide what kinds of data to release in the future. So if I think about these data streams as sort of sources or spigots that I turn off or direct or release filtered versions of them, the data I've already released, okay, I've already released it, but how can I get back information from the system so that I can make better decisions in the future? So what is a better decision? It might be sort of times at which I choose not to release information. It might be downcoding that data. And so one of the mechanisms we're playing with is a notion of something called a trace audit, sort of like traceroute. Just like traceroute, people can lie when they're responding to your request for a traceroute. But you can imagine third-party services that would agree as part of their label as running responses to requests about where your data has been released and when. And of course, they can lie and be fraudulent, but you have all kinds of legal recourse in that case. This is just the idea of starting to bring some instrumentation back into the process so that when you release your data streams to particular third parties to be passed on, you have some feedback as to where that data is going. And the hard problems there are then having to do with making that data you get back being something that anyone can do anything with, so that anyone will pay any attention to, that you know how to actually process. So as is common knowledge now, the problems with security and computer security has to do with the fact that of the user interface to setting of those security mechanisms, to checking of them, to verifying of them. And so here we have all those problems in spades as well. And again, so many of these problems seems to become user interface design problems and good data visualization. Just to give you an example, when we designed Peer, in many ways Peer is designed in the wrong way. And one of the things we're doing this summer, because my location trace goes directly up to a private account in the Peer system. So this summer we're pulling it apart. We're putting in an instantiation of a personal data vault. And then I will release certain streams of my data to Peer, which is sort of that model we'd like to have for that level of indirection to third parties. But something we did design into Peer from earlier is the ability to go and see what computation led to the inference that the system is making. And so it's that kind of interface that you design into your system so that it is self-reporting as to how particular inferences are made that seems important to design into this kind of system as well. And so privacy is and these privacy supporting architectures is one of the areas that I think is most important for us to do, particularly in the university setting, where we're not as we're not in. There are a lot of commercial applications coming out, and there's lots of reasons to mine the data. And so I'm not expecting somebody who's in the business of optimizing for profit for necessarily taking a look at this question about how should we introduce this level of indirection into the problem. But I think it behooves us all in the end to at least look into providing an alternative, more privacy-preserving way of going about doing these types of applications. There'll still be plenty of commercial services to be offered off of this, but this seems to be a more responsible way of building the applications. So just to finish up, I talked about a wide range of applications, relatively mundane components of technology that go into them. And hopefully these applications will be commonly moved forward because there are so many common components to them, and some issues such as privacy that really pervade all of them. And so just to finish up, this is very much a case of, if you can't go to the field with the sensor you want, go with the sensor you have, and about really leveraging that combined power of the internet and the mobile device. And with that, I'm done. And I loaded up a bunch of other URLs here if anyone's interested. Oops. So ask me some questions, I'll be terribly insulted. Yes?
Some of these applications are immediately useful to the first person that uses them, whereas others you have to sort of get over this.
It's my line.
Effect. I'm wondering what your experience is
Yes.
trying to incentivize people to get over that network.
Good. So not a single one of them depends on large numbers because as you were still around then, there's sort of this, along with being traumatized from work in distributed sensing because of the actual cost of each point of measurement. It's also just, it's related to it is that sort of traumatized by it's just so slow to get out there and deployed. And so I didn't want applications where I had to imagine that I had, 3%, 5%, or 10% penetration in a particular area before it became useful. So for example, one of the first applications we did with GPS time series was doing traffic monitoring on side streets that aren't instrumented, right? Because you can look at the progression of the GPS and you can get an indication of how traffic is moving. And you can go and build a little version of that application. It's all very easy to do, but then okay, so how was I going to get some percentage penetration around Los Angeles so that there would be enough people out there on side streets who were generating this information? That seemed like a good thing for a commercial endeavor to go do, right? Which is now what's happening, or you have the Millennium Project. I did not have the creative idea nor the chutzpah to go and rent 1,000 rental cars and have people write the Millennium Project that Alex Bayan from Berkeley did with Nokia, which is he rented 100 and then 1,000, I think, rental cars and had students drive up and down the highways there to show, because he also does this very complex modeling, and it was important, and so very cool work. But that's an example of something that doesn't scale down. So each of these applications, I was rather stuck or obsessed with the notion of choosing applications that scale down. So Peer is an example of an application that scales down. I using it all by myself, nobody else using it. I'm using my location trace as an index into existing models. I'm not depending on data that's being contributed to create the model or the data set. This map was created by 10 people who happen to be already going around the park area because that's part of what they do in their everyday. Some of the other applications that will happen in the future could be if this stuff is widely adopted, because it will be. But all of these campaigns are in some sense all about that, making it be very narrow, sort of, narrow band in that sense. So you don't have to have large populations to have some chance that it will work. So they're all intended that they scale down. They don't just scale up. If something scales down, then hopefully it can build up to numbers that eventually it scales up. The wellness applications are all very individually focused as opposed to collecting data from people to build some model. I think building those bigger models and the epidemiology story and all of that will all be tremendously exciting, but I can't figure out how to incrementally, sort of get there. Yeah.
So if a lot of the applications only use scaled down versions where I use only my data, why do we need to share it with a health ward, with a data ward, and then have it audited whether it's being shared correctly?
Good. Yeah. So just keeping it on your device is just a reliability issue. So I want it off my device. There are two reasons. The very minimal reasons is reliability. So I don't know if you've ever dropped or lost your, okay, so then you say, why not on my device, but on my, right, so my home computer has the same problem as my device, right? And if I'm talking about wanting to have and having health applications that build up more seriously over time, I really want it sitting someplace in the cloud.
But the cloud could just be an encrypted backup.
Exactly. So at some level, this is just an institutionalizing that. It's just an encrypted thing in the cloud. At a minimum, that's all the data vault is. However, a lot of these applications, even though they're not about aggregation, they are about services. So I want to be a part of a, one of the interesting things about this Robert Wood Johnson Foundation proposal we submitted, we actually submitted it with a clinic that's in South Central. And we went to them and talked to them about this mobile personal sensing and all this stuff and this feedback about looking at your own health behavior. And they sort of looked at us and said, we get it, but for our populations, there's not this sense of what they refer to as sort of agency of I'm going to do my self-monitoring and change my health behavior, right? These are people who are struggling in many respects. That's just not culturally how they work. So they have community health workers that work with subsets of the people there to help them do behavior change. They go and they're that sort of, they fill this huge gap that exists between the clinician and actually doing the kinds of health behavior that they need to do in order to change their health situation. So you want to be running a coaching application, a health monitoring application, tie into a social network of set of people who are going to help you do that behavior change, whether it's an Alcoholics Anonymous or whatever your analogy might be, Weight Watchers, what have you. So if you're never doing any sharing, you just need a private container in the cloud. But I think the power of these things will come through sharing. Some of it will be through those sorts of things. Some of it will be through things we might consider more coercive or just simply capitalism at work, which is that I'll get discounts on my insurance or rebates on my health insurance or what have you, right? The city officer in New York wants to make it mandatory to do a certain level of monitoring and reporting because he sees it as the only way that he's going to keep health. I mean, if we just dealt with obesity in this country, there is a whole set of follow-on conditions, hypertension, diabetes. If you think about the impact at cancer, if you think about the impact on the healthcare system of just dealing with that, there are reasons why if one was into draconian measures, that would be the place to put it. So, long answer.
I'm wondering how you actually think about the space of applications that are possible with an architecture like this. So the ones you described seem to have this flavor that this personal sensing lets you do certain things way more efficiently than would be otherwise possible. Mm-hmm. I wonder if there are a second class of applications that would actually not even be possible without mobile personal sensing or not. Is that a distinction there in your mind?
So I'm glad you asked that question in part because I should have said, right, so there are these people who do, what's the guy, Seth Robert or something, that self-analyze, there's some term they use. So all these people who obsessively who document all their behaviors on websites, this self-analyzed, come on, hasn't anyone been to these sites? There's some better term than self-analyzed. The self-examined life, something like that. And so he's a really interesting guy. I think he's a stat professor at Berkeley who started off, he had a whole set of health conditions and he started doing this very, very detailed measurement of what he ate and what soap he used and and started tracking all these things. And just using the web as a vehicle for that and for sharing and things of that sort. So clearly there are a set of these things that if you are focused on it enough, that you can do without the device, that the device, as you said, makes easier. I think in some contexts, it makes it easier to the point at which it wouldn't have been done. For many people, if you take into account human behavior, they simply wouldn't have done it. Now, the case still has to be made whether they'll do it this way either. Right? It's too early to know that. But this is just not a quantitative or systematic, but it has a feel to it because people carry these devices around with them that for some people it might be that qualitative difference, just not just the quantitative. In general, this area of retrospective self-report, switching retrospective self-report to in-the-moment self-report, it's still self-report, I can still lie. right? But the nature of bias and lying that happens in the moment self-report versus retrospective self-report is very different for many different populations of people. I'm sure there are people who are completely honest and have perfect recollection in both cases, right? So in that context, I think it's a matter of a qualitative difference. It's yet to be seen how we can do the user interface design and the reminders. Remember, these are also devices that can be triggered by location and time to remind you to do things and prompt you to do things, to notice that you're not doing them. And as the machinery and the learning part of it gets better, can get more and more sophisticated as to when they decide they actually need information versus when you seem to be having the same kind of day you had before. All those kinds of things can get better and better. I think all of my examples, you could find another way of doing them if you can imagine people saying, for example, go back and say they were at home and at work, and these are the other things they did during the day, so you have an equivalent of their location trace. Yeah?
You made a pretty compelling argument for using sort of mobile personal devices for these sort of sensor applications. I was wondering, do you see sort of other classes of applications for mobile devices, or do you have any opinions on like people using mobile devices for computation and storage augmentation? I'll carry my life around on my phone.
That particular one, I have an observation that's not particularly educated observation, which just sounds stupid, right? So, before that, I was about to say, I don't know, but that one just strikes me as stupid. So, why would I only carry my life? And the thing that has to be powered is the place that you would do that. So no, I don't. I think the days of the sort of SETI at home notion, for many reasons, and we joked with sort of SETI on phone kind of a thing. It's not a great model because it's also not even the most energy or reliability or anything way of actually doing things, to leave all our computers always plugged in case that we would run some computation for somebody. But I'm not an expert on all that's been uploaded to and downloaded from and used by, people off of the App Store. There are clearly a lot of these apps that are about, location-based. I didn't really talk about location-based services. These are more location trace-based. It's not just instantaneous location-based. Clearly lots of just location-based everything that tends to be possibly useful, but I don't have anything particular to say about. I don't think I have anything particularly useful to say about that otherwise. Yeah?
Are your tools freely available and open source to review?
So everything we do is thus far open source. I'm supposed to say, my colleagues want me to say thus far because they make the point that as we transition out of being a center, we shouldn't cut ourselves off from possibly doing something else. But everything is open source. Whether the particular set of things is currently up there in an easily downloadable way without sending me email is just a matter of where the project is in its phase right now. But if you send me email and say, where is this and can we get a version of it, the answer will almost always be yes, and somebody else has probably asked for it, so it's pretty reasonably available. So this rapid campaign platform that caseGÇ Reddy has been the primary person on, but with others, is an example of that. So we've given out to a few other people, and we're delighted to see that happen. Thank you.